only for cos and cot. Cos inverse minus x is pi minus cos inverse x. Cot inverse minus x is also equal to pi minus cot inverse x. If x is positive, theta is also positive, range is positive. If x is negative, theta is negative. That is regarding the first property is considered. Cot 180 minus theta is equal to minus cot theta, because this comes in second quadrant. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, the faculty of mathematics, Vidhyaashram PU College, the Temple of Excellence. In last class, we have discussed regarding inverse trigonometrical functions of sine, cos, tan, cot, secant, cosecant, the range, domain and the principal branch, and a few problems based on those range and domain. Now in this section, I am going to discuss regarding the properties of the inverse trigonometrical functions, the very important properties of inverse trigonometric functions. The first property is to prove that sine inverse of minus x is equal to minus of sine inverse of x, where x belongs to minus 1 comma 1. The domain is minus 1 to 1, the closed interval minus 1 to 1. Now you know this in allied angle you might have been studied. Sine of minus theta is also equal to minus sine theta. If theta is replaced by minus, you will get minus sine theta. The same concept, sine inverse of minus x is also equal to minus of sine inverse x. Let us consider, let sine inverse of minus x is equal to theta. Now this implies sine theta is equal to minus x, right? Sine theta is equal to minus x, or I can write x is equal to minus sine theta, just multiply by negative sign. This implies x is equal to, what is minus sine theta? Sine of minus theta is equal to minus sine theta. So this minus sine theta can be written as sine of minus theta. Now just take inverse for this. This implies sine inverse of x is equal to minus theta. Sine inverse of x is equal to minus theta. Now multiply by negative sign. If you multiply this, what you will get? Minus sine inverse of x is equal to theta. Therefore, substitute the value of theta. What is theta? Theta is nothing but sine inverse of minus x. Sine inverse of minus x is equal to minus sine inverse x, where x belongs to minus 1 comma 1. That's it. So sine inverse of minus x is equal to minus of sine inverse x. Listen to me. Let sine inverse of minus x is equal to theta, which implies sine theta is equal to minus x multiplied by negative sign. So what you will get? X is equal to minus sine theta. Minus sine theta can also be written as sine of minus theta, because sine of minus theta is minus sine theta. This becomes sine of minus theta. Now take the inverse for this function. So x is equal to sine of minus theta implies sine inverse x is equal to minus theta. Just multiply by negative sign. Minus sine inverse x is equal to theta. Therefore, substitute the value of theta. What is theta? Theta is nothing but sine inverse x. Sine inverse of minus x. Sine inverse of minus x is equal to minus of sine inverse x. This is the first property. Let us take for example. Let me take an example. What is the value of sine inverse 1 by 2? The principal value of sine inverse 1 by 2 is 30 degrees. 30 degree can be written as pi by 6. Suppose if it is negative sine inverse of minus 1 by 2, then the value is also equal to minus 1 by 6. Suppose if it is sine inverse 1 by root 2, the value of sine inverse 1 by root 2 is pi by 4. Pi by 4 is the principal value. Whereas for sine inverse of minus 1 by root 2, the principal value is minus pi by 4. So that is why the range of sine inverse x is minus pi by 2 to plus pi by 2. So the domain is minus 1 comma plus 1, and the range is minus pi by 2 to plus pi by 2. Minus pi by 2 comma plus pi by 2. So if x is positive, theta is also positive, range is positive. If x is negative, theta is negative. That is regarding the first property is considered. So that is sine inverse of minus x is equal to minus of sine inverse x. Now come to the second. Similarly for cos, prove that cos inverse of minus x is equal to pi minus cos inverse x, where x belongs to minus 1 to 1. So what is to prove? Cos inverse of minus x is equal to pi minus cos inverse x. This is very important property. Now you know this cos of minus theta is equal to plus cos theta itself, whereas sine of minus theta is minus sine theta, but cos of minus theta is equal to plus cos theta. It won't change us. Now let us consider this. Let cos inverse of minus x is equal to theta. Now this implies cos theta is equal to minus x. Cos theta is equal to minus x. Now that is, this cos theta can also be written as, or if you want, you just multiply by negative sign. That is minus cos theta is equal to x. Okay. Now there is one formula you might have been studied in allied angles. Cos 180 minus theta is equal to minus cos theta, because 180 minus comes in second quadrant. In second quadrant, sine is positive, cos is negative. So therefore cos 180 minus theta, 180 minus theta comes in second quadrant. In second quadrant, cos theta is negative. Therefore cos 180 minus theta is equal to minus cos theta. This implies minus cos theta can be written as cos of 180 minus theta is equal to x. Okay, see here, minus cos theta can be written as cos of 180 minus theta. So cos 180 minus theta is equal to x. Cos 180 minus theta is minus sine theta. You will get the same step. Now this implies, if you put inverse for this, cos inverse of x is equal to, cos inverse of x is equal to 180 is nothing but pi minus theta. Therefore cos inverse of x, what is x here? Cos inverse of x is equal to pi minus, what is theta? Theta is nothing but cos inverse minus x. Interchange this, transfer this. So therefore if you transfer this, cos inverse of minus x is equal to pi minus cos inverse x. This is the proof. So cos inverse of minus x is equal to pi minus cos inverse x. This is very important property. See here, listen. Let cos inverse of minus x is equal to theta, which implies cos theta is equal to minus x. So multiply by negative sign, transfer minus sign to this side, minus cos theta is equal to x. Minus cos theta can also be written as cos 180 minus theta. Cos 180 minus theta is minus cos theta. So cos 180 minus theta is equal to x. So if you take the inverse for this, cos inverse of x is equal to pi minus theta. Cos inverse of x is equal to pi minus theta. What is theta? Cos inverse minus x. Interchange this, transfer minus to this side. So minus cos inverse of minus become cos inverse of minus x is equal to pi minus cos inverse x. So therefore cos inverse of minus x is equal to pi minus cos inverse x, where x belongs to minus 1 to 1, the closed interval, and the range is from 0 to pi. Now the very important point here to be noted is, if x is positive, theta is positive and lies from 0 to 90 degree. If x is negative, theta is positive and lies from 90 to 180 degree. This is very important concept. So in this case, in cos inverse of x, in this case, if x is positive, theta is positive and lies between 0 to pi by 2. Suppose if x is negative, theta is positive and lies between 90 to 180. That is pi by 2 to pi. So this is very important concept. That is why cos inverse is negative. We are going to use pi minus cos inverse x. Now let us come to an example. Let me take an example. I will rub this. I will take an example. Now for example, let us consider an example. Cos inverse of 1 by root 2. Cos inverse of the principal value of cos inverse 1 by root 2 is pi by 4. Okay, suppose if it is like this, cos inverse minus 1 by root 2 means The principal value is pi by 4. Since cos inverse of minus x can be written as pi minus cos inverse x. This is pi minus pi by 4. This is equal to, take LCM, 4 is the LCM, 4 pi minus pi. This is equal to 3 pi by 4. Very, very important. You will get this type of question for 1 mark. Suppose if it is like this, cos inverse root 3 by 2. So this is nothing but cos inverse of root 3 by 2 means cos root 3 by 2. So this comes for 30 degrees, because sin 30 is 1 by 2, cos 30 root 3 by 2. 30 degree can be written as pi by 6. If the same problem is cos inverse minus root 3 by 2, then for minus root 3 by 2, we are going to use pi minus pi by 6. So take LCM, 6 is LCM, 6 pi minus pi, that's equal to 5 pi by 6. See here. So if x is positive, theta is positive and lies between 0 to 90 degree. If x is negative, theta is positive and lies from 90 to 180. What is 3 pi by 4 is 45 degree. 45 into 3 means this is 135 degrees, greater than 90 degrees. Again here, cos inverse root 3 by 2. Root 3 by 2 means pi by 6. Pi by 6 means 30 degrees. If it is negative means it should be greater than 90 degree. 5 pi by 6. 5 pi by 6 is nothing but 5 into 3. That is 150 degrees. Right. So therefore, if cos is negative, cos inverse of minus x is equal to, we are going to use pi minus that particular angle. Pi minus cos inverse of x. Okay. Now let us come to the next one. Next property. What is the next property? To prove that tan inverse of minus x is equal to minus tan inverse x, where x belongs to R, the real numbers. Now let us consider tan inverse of minus x is equal to theta. Same type. This implies tan theta is equal to minus x. Okay. Now R, which implies minus tan theta is equal to x. Tan inverse of minus x is equal to theta. Tan theta is equal to minus x. Therefore, minus tan theta is equal to x. This implies theta can be written as minus of tan inverse of x. What is theta? Tan inverse minus x. So therefore, tan inverse of minus x is equal to minus tan inverse of x. This is the proof. So very simple problems here. Let us consider tan inverse minus x is equal to theta, which implies tan theta is equal to minus x multiplied by negative sign minus tan theta is equal to x, which implies theta is equal to, this theta is equal to minus of tan inverse of x. So what is theta? Theta is nothing but tan inverse minus x is equal to minus of tan inverse of x. That is the proof. Now let us take for example, if I take, let us take for example tan inverse of 1. Tan inverse of 1 is pi by 4. Whereas tan inverse of minus 1 is minus pi by 4. So if it is like this, tan inverse of root 3. So tan inverse of root 3. Tan inverse of root 3 is nothing but 60 degrees. 60 degree can be written as pi by 3. Whereas tan inverse of minus root 3 can be written as minus pi by 3. Now let us come to the next property. The next property is this fourth one. Same. Similarly, we are going to study the remaining properties secant, cosecant and cot. Now let us come to this property. Prove that secant inverse of minus x is equal to pi minus secant inverse of x. So where x mod x is greater than or equal to 1. Same type as that of cos. Let us consider, let secant inverse of minus x is equal to theta, which implies minus x is equal to secant theta. Minus x is equal to secant theta, or so this x is equal to minus secant theta. This implies x is equal to, so secant theta can also be written as secant of 180 minus theta is equal to minus secant theta. You know, again secant 180 minus theta comes in second quadrant. Sine is positive, remaining overall negative, secant is negative. Secant 180 minus theta is equal to minus secant theta. So this minus secant theta can be written as secant of 180 minus theta. See here, Secant 180 minus theta is minus secant theta. Just take the inverse for this. This implies secant inverse of x is equal to 180 minus theta. 180 minus theta can be written as pi minus theta. Therefore, secant inverse of x is equal to pi minus, what is theta? Theta is nothing but secant inverse of minus x. Interchange this, transfer this. Therefore, secant inverse of minus x can also be written as pi minus secant inverse x. This is the proof. So, secant inverse of minus x is equal to pi minus secant inverse of x. See here, let us consider secant inverse of minus x is equal to theta, minus x is equal to secant theta, multiply by negative sign, x is equal to minus secant theta. Since secant 180 minus theta is equal to minus secant theta, so x is equal to minus secant theta can be written as secant 180 minus theta, because secant 180 minus theta is minus secant theta. So take inverse for this. X is equal to secant 180 minus theta implies secant inverse of x is equal to 180 minus theta. 180 minus theta is nothing but pi minus theta. Secant inverse of x is equal to pi minus, what is theta? Theta is secant inverse of minus x. Interchange this, transfer secant inverse minus x to left hand side. Secant inverse of minus x is equal to pi minus secant inverse x. So, secant inverse of minus x is equal to pi minus secant inverse x. So, let us take for example, secant inverse of 2. Secant inverse of 2 can be written as cos inverse 1 by 2. This is nothing but cos inverse 1 by 2 means cos 60 degree, sin 60 root 3 by 2. Cos 60 is equal to 1 by 3. This can be written as pi by 3. Suppose if it is secant inverse minus 2, then this can be written as cos inverse of minus 1 by 2. This is nothing but pi minus pi by 3 is 2 pi by 3. 2 pi by 3. Okay, let me take one more problem. Suppose if it is secant inverse minus root 2. So straight away, for root 2, you are going to get pi by 4. Secant inverse root 2 can be written as pi minus pi by 4. That is nothing but 3 pi by 4. Otherwise, convert this to cos, or you can also write like this, cos inverse minus 1 by root 2. So, this is pi minus pi by 4. This is also equal to 3 pi by 4. This is the method we are going to use to solve secant inverse and cos inverse if it is negative. Now let us come to the next property, that is prove that cot inverse of minus x is equal to pi minus cot inverse of x. Same type. Let us consider, let cot inverse of minus x is equal to theta. This implies cot theta is equal to minus x, or interchange this, that is minus x is equal to cot theta, multiply by negative sign, x is equal to minus cot theta. Since there is one formula using in allied angles, you know the formula for cot 180 minus theta is equal to minus cot theta, because this comes in second quadrant. In second quadrant, cot is negative except sign, remaining are all negative. This can also be written as cot of pi minus theta is equal to minus cot theta. Substitute here. This implies x is equal to minus cot theta can be written as cot of pi minus theta. Take inverse for this. This implies cot inverse x is equal to pi minus theta. So therefore, cot inverse of x is equal to pi minus, what is theta? Theta is cot inverse minus x. Cot inverse of minus x. Interchange this. If we interchange, transfer this. Therefore, this cot inverse minus x can be written as pi minus cot inverse x. This is the proof. So, therefore, cot inverse of minus x is equal to pi minus cot inverse x. So, only for cos and cot, cos inverse minus x is pi minus cos inverse x. Cot inverse minus x is also equal to pi minus cot inverse x. So, whenever cot and cos are negative, just put pi minus cot inverse x or pi minus cos inverse x. Now let us take an example. I will take one example for this. Let us consider, find the value of cot inverse of 1. Cot inverse 1 is pi by 4. Suppose if it is like this, cot inverse minus 1 means cot inverse of minus 1 can be written as pi minus pi by 4. 4 pi minus pi is 3 pi by 4. This is the simplified answer for a cot inverse of minus 1. Cot inverse of plus 1 is 1 is pi by 4. Cot inverse of minus 1 is 3 pi by 4. So that is regarding the properties. Now let us come to the properties. Now, so before that, let me construct this table. So entirely depends upon this table. 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Okay, let me write the three important ratios: sine, cos and tan. Okay, so here in the previous class I explained this is pi by 6 radians, this is pi by 4 radians, this is pi by 3 radians, this is pi by 2 radians. Now you know sine 0 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 is 1, and reverse this. Cos 0 is 1, cos 30 root 3 by 2, cos 45 1 by root 2, cos 60 is equal to 1 by 2 and cos 90 is equal to 0. Tan, divide, 0 by 1 is 0, 2 gets cancelled, this is 1 by root 3, 1 by root 2, 1 by root 2 gets cancelled, 1, 2 gets cancelled, root 3 by 1 is root 3, 1 by 0 which is infinity, not defined. So once if you know this table, it's very easy for you to solve the problems, to write the principal value for the given trigonometrical ratios. Now here what is given? The first one is sine inverse of minus 1 by 2. So for sine inverse, so here 1 by 2 is for 30 degrees. Since this is negative, therefore the principal value for this is minus of pi by 6 radians, or this is nothing but minus 30 degrees. Minus pi by 6, that is minus 30 degree. Come to the second problem, cosecant inverse 2. Cosecant inverse 2 can also be written as sine inverse of 1 by 2, because you know this formula, cosecant inverse x is also equal to sine inverse 1 over x, the reciprocal relations. So cosecant inverse 2 is also equal to sine inverse 1 by 2. Again sine inverse 1 by 2 is nothing but pi by 6 radians. So this is sine inverse of plus 1 by 2, it is plus pi by 6. This is sine inverse minus 1 by 2, therefore it is minus pi by 6. Okay, now let us come to the next problem. Tan inverse of root 3 minus root 3. So see here, for tan the root 3 is for 60 degree, pi by 3. Since tan 60 degree is equal to root 3. Okay, so this is minus, therefore this can be written as 60 degree means this is pi by 3 radians. Tan inverse of minus 3 is equal to minus pi by 3. See here, tan of root 3 is for 60 degree. Since it is negative, therefore it is minus pi by 3. Again tan inverse, since tan 45, you know tan pi by 4 is equal to 1. Tan inverse of minus 1 can be written as minus pi by 4. These are the principal value of tan inverse root 3 and tan inverse of minus 1. Now let us come to the next problem. So cos inverse of 1 by 2. For cos inverse 1 by 2. So 1 by 2 cos inverse 1 by 2 is nothing but pi by 3, 60 degrees. This is equal to 60 degrees, pi by 3 radians. Cos inverse of 1 by root 2. Cos inverse of 1 by root 2 is nothing but pi by 4, 45 degrees. Now cos inverse of root 3 by 2. Cos inverse of root 3 by 2 is nothing but 60 degrees, that is pi by 3. Secant inverse of minus 2. Since you know the formula, secant inverse x is also equal to cos inverse 1 by x. This can be written as cos inverse of minus 1 by 2. Since cos of 1 by 2 is equal to pi by 3, since this is negative, negative can be written as pi minus pi by 3, because you know the formula, cos inverse of minus x is equal to pi minus cos inverse x. So pi minus pi by 3, take LCM, 3 is the LCM, 3 pi minus pi is equal to 2 pi by 3. 2 pi divided by 3. This is very important problem. You will get it for 1 mark. Secant inverse minus 2 can be written as cos inverse minus 1 by 2, because secant inverse x is cos inverse 1 over x. Since cos is negative, if it is negative means cos inverse of minus x is equal to pi minus cos inverse x, pi minus pi by 3. So that is 3 pi minus pi by 3 is equal to 2 pi by 3. Right? Hope you are following. Very easy. Once if you know the table, it's very easy to write the solutions for this. Now come to the next. Find the value of secant inverse 2 by root 3. Same. This can be written as secant can be written as cos inverse of root 3 by 2. So this implies cos inverse root 3 by 2 means this is nothing but 30 degrees is nothing but pi by 6 radians. Cos sin 30 is 1 by 2. Sin 30 1 by 2. Cos 30 root 3 by 2. So cos inverse root 3 by 2 is 30 degrees pi by 6 radians. Cosecant inverse root 2 can be written as same sin inverse of 1 by root 2. These are all the reciprocal relation. Sin inverse 1 by root 2 is nothing but 45 degree, because sin 45 is equal to 1 by root 2, pi by 4. Now come to this cosecant inverse minus root 2 can also be written as sin inverse of minus 1 by root 2. Sin inverse of minus 1 by root 2 is minus pi by 4. Okay. These are the ratios. Suppose if it is like this. Secant inverse of minus 2 by root 3. Secant of minus root 2 by root 3 can also be written as cos inverse of minus root 3 by 2. Since root 3 by 2 means pi by 6, this is negative. This can be written as pi minus pi by 6. Cos inverse of minus root 3 by 2 can be written as pi minus that particular angle, pi by 6. So take LCM. 6 is the LCM. 6 pi minus pi. This is equal to 5 pi by 6. This is the answer. These are the few problems based on the properties of inverse trigonometric functions. So these problems are very important. So hope you are following. Definitely you will get one question from this for 1 or 2 marks. So in the next class we have few more properties that we will discuss in the next class. Thank you very much. Practice. Once if you know the table, it is very easy for you to solve the problems. Practice. Thank you very much.